In this lab, you're going to use a demultiplexer to create a more efficient version of the open sign, which I happen to have right here. Notice I'm using 4 7-segment displays. They are common cathode 7-segment displays, meaning that if you want to light up a segment, you send the top of it. Remember, common cathode, you send the top pin or the common pin to ground, and then if you want to light up a segment, you have to send that segment to 5 volts of power. So here on the bottom, I'm lighting up in order to make the 0 for my open sign, I'm lighting up segments A, B, C, D, E, F, but G I do not have connected. So I have powered all the segments except for G. All right, this is going to be a rather strange application of a demultiplexer. Now this is a demultiplexer chip. I have one data line coming in and it is actually grounded. So in other words, my data is just going to be 0 and I'm going to select where I want that output to go using these 2 selector switches. Now remember, these are 7-segment common cathode displays. That's why my data is a 0, because when I send a 0 as input to one of these common pins, it'll light up the 7-segment display. And let's just go through it and see if this makes sense what's going on. If I flip down key 1, which I will do right now, let's see. Key 1 is flipped down. The P is now lit up. Well, why is that? Well, because I selected a 0, 1, and so the output will go to Y1. And again, the data is a 0, so that means I have a 0 coming in to this 7-segment display, and you can see that Y1 is now off. If I flip down switch 2 or key 2 and flip up 1, I now have the 3rd 7-segment display lit up, that's the E, and if I flip them both down, of course I have the N lit up. So if I were to flip through these fast enough, I'd have to do it really fast, I could get my open sign to run quickly enough. Well, I'm not going to be able to do it quickly enough, but I'm missing the E, I think, there. But I could do it quickly enough that it would play a trick on your eye. It would actually look like each segment was lit up continuously, and I could actually use like 1/4 the power. And actually, a lot of 7-segment display signs are done like that. It looks like all of the 7 segments are lit up at once. All of the 7-segment displays are lit up at once, but they're really not. They're each just being lit up one at a time in very quick succession. Let me just show you what that looks like if I try to do it more rapidly on the next slide. All right, so here again is my open sign. Now I've connected this to a counter and I'm going to flip through. You're going to learn how to do this eventually. I'm going to flip through all of the 7-segment displays. And let's see if this looks reasonable. Well, it doesn't look great, but if I made it count even faster, you could see that it would look like, it would create the illusion that all of the 7-segment displays were lit up at once, and you would see that open all lit up, and it would actually, you'd be doing it by using less energy than if you lit up all of them all of the time. And I hope that makes sense. All right, I think you're ready to get going on the lab.